Our next problem involving application problems with systems of linear equations involves flying airplanes. And I have an airplane, well, I don't have an airplane, but the airplane that we're looking at, we know that it can fly 3 hours. In 3 hours, it can fly 450 miles if it's flying with the wind. On its return trip, it's going to fly into the wind. And we know that's going to take longer. And so he can fly that same 450 miles on the way back, but it's going to take him 5 hours this time. So the question that we're kind of wanting to know or to see if we can find out is, well, what's the speed of the wind? Or what is the speed of the airplane in still wind or in the absence of wind? So let me show you how we kind of set that problem up in these distance equals rate times times problem. So what I'll do is I'm going to set up my rate times my time equals my distance. I'm going to select a variable. What I don't know is the plane speed in still air. So I'll say still air. And I can set that as my variable or one of my unknowns. And then my y is the wind. I don't know the speed of the wind. Those are the two things. So what I can look at now is I want to add those two things on up. So the rate on the first one, I have x, the speed of the plane in still air, plus the help of the wind, which is y. That's one rate. I know that when I have still air plus the help of the wind, it takes me 3 hours to fly 450 miles. Can you start to develop the second one? What's the next equation that I'm going to need to build? Two equations? Or two unknowns? I need two equations. Well, the next one is the rate of the plane in still air fighting against the wind. So I'm going to subtract that on that particular time, and that's going to take me 5 hours to go the 450 miles. So the two tricky things in identifying this conversation is, first of all, I need to realize it's a distance equals rate time times problem. And when I do that, I'm able to start to kind of build a table. The other tricky part is to figure out what are my variables. And the problem will give us clues towards things that we don't know. And those we will assign as variables. Let's continue solving this problem out. This is basically a system now. So I have 3 times x plus y equals 450, and 5 times x minus y equals 450. Let's divide the top one through by 3 and divide the bottom one through by 5. So then I'll have x plus y equals 150, and then I'll have x minus y equals 100, no, not 150, 90? 90. 5 divided by, so I'm going to divide this one by 3, divide this one by 5, and dividing that by 5 gives me 90, correct. Here's my next system. I'm in luck. The system right there shows me that I have terms that I can eliminate. So I'll have 2x equals 240, x equals 120. And in this particular case, I allowed the plane in still air, its speed in still air, to represent the x. So that is 120 miles per hour. And then I can take this value and put it back into any equation that might be helpful. How about right here? So x minus y equals 90. 120 minus y equals 90. Looks like y equals 30. So the speed of the wind is 30 miles an hour. That's either helping me or pushing against me, depending on which direction I was traveling, obviously.